This problem is asking us to evaluate the derivative of the inverse. So we want the derivative of the inverse of this function, not just the derivative of this function. And to find the derivative of any inverse function, our textbook derived formula looks like this. The derivative of the inverse is just 1 over the derivative of the function. So let's first find f prime of x, the derivative. To do that, we'll differentiate term by term. So differentiating this, we've already derived that in our textbook. The derivative of arctangent or inverse tangent is 1 over 1 plus x squared. And just a note, if it wasn't x, if it was x squared, you got to use the chain rule, because we're implicitly using the chain rule right now. The derivative of the innermost function there of x is just 1. So, okay, so the derivative of f, we're still working on it. The derivative of arctangent is 1 over 1 plus x squared, and then the derivative of this term, 3x squared, that's the power rule. 2 comes down and multiplies, so that makes 6x. Okay, and we haven't found the derivative of the inverse function yet. To find the derivative of the inverse function, the formula I pulled up on the side, the derivative for any inverse function, I'm going to drop the of a notation for just a second. I'm writing with a laptop mouse. But the derivative is going to be 1 over the derivative of the original f of x, not the derivative of the inverse. So. Okay, so we just have to plug this into the denominator down here. And so since, oops, what I meant to do. There we go. Okay. So since we're evaluating at a equals 0, it's like we're plugging in 0 where a is, right? So we're evaluating this whole thing at 0 for x. Okay. So instead of saying the derivative of f at 0, we can just, at x, we can put in a 0 in its place because it's no longer a variable. So the derivative of f at 0 is going to be, let's see, plugging in 0 everywhere for x. You get 0 squared is 0, 1 plus 0 is 1, 1 divided by 1 is 1, and then this is 6 times 0. So if you plug in 0 into the derivative, you get out 1. Okay? I plugged in 0 everywhere where there was an x in the derivative, I got out 1. So we can just plug in 1 into the denominator here, because if I'm plugging 0 into the derivative, we already found out that that's 1. So this whole thing is 1 over 1, which is equal to 1. So we did it. The derivative of the inverse at x equals 0 comes out to be just 1.